Let's have a look at question 37 in this video. So we have a food processor that wants to compare two preservatives for the effects of retarding spoilage. Now we have 16 cuts of meat that are treated with preservative A and 14 are treated with preservative B, and the number of hours until spoilage begins is recorded for each of the cuts of the meat. So we have them here. These are the sample means, so the averages of the samples for A and for B, the sample standard deviations for A and for B, and we have the following hypothesis: either the difference is 0 or different than 0. Now, assuming that the number of hours until spoilage is normally distributed and that the population variances are equal, so we assume equal variances, we are performing a t-test. Now, what's going to be the rejection region for this test? Now, let's have a look here on the right. I wrote the sample data. I wrote the data for A, the data for B, the means, the sample standard deviations, the number of observations, and these are the hypotheses, which is the same as what they say here. The difference is 0, meaning that the means are equal for both preservatives, or they are different from each other. That's what we're testing. Now in this question we only want to know the rejection region, so we want to know the critical value because we're doing a t-test and we know that the t-test is a symmetrical test. So what we're having is a t-test, which is a symmetrical test around the mean of 0, and because it is two-sided, we're interested, the test is two-sided, we're interested in the rejection region both on the right side and on the left side. So our job now is to find out these critical values. This is our goal. Now what are the critical values in this case? The key point that we keep in mind now is that the population variances are assumed to be equal. So we assume equal variances, meaning that the critical value at 5% level alpha, 5%, divided by 2, because it's spread over two sides, over two tails, is going to have the degrees of freedom of n1 plus n2 minus 2. Now, what's that going to be? The critical value at 2.5% level, because we divide 5% by 2, n1 plus n2, that's equal to 16 plus 14 minus 2. So let's write that down. That's going to be 16 plus 14 minus 2. Meaning that we're having a critical value t, over here at 30 degrees of freedom. So with the corresponding significance level and 30 degrees of freedom, we're looking, 16 plus 14, that's 30 minus 2, it's 28, 28. So we're looking for the following critical values in the distribution of the t values. Now if we look them in the table, we'll find out that those corresponding values are 2.048, and because it's symmetrical, we're going to have a negative corresponding value of minus 2.048. So if we have a look at the answer key, they say that we would reject if t is less than minus 2.048, so it would be this area, which is true, or greater than 2.048, which would be the other shaded area. So indeed the answer is true, and that's it.